Good morning and welcome to Back to Basics, Object-Oriented Programming. Thank you for coming. I'm Amir Kirsh. I'm a lecturer at the Academic College of Tel Aviv-Yafo and Tel Aviv University. I'm also a researcher, a visiting researcher this year at Stony Brook University, New York. I'm the developer advocate at Incredibuild. I will have a slide about that. And the co-organizer of the CppCon conference and meetup group in Tel Aviv. At Incredibuild, we do build acceleration. So if you are suffering from slow CI pipeline, builds, static code analysis, testing, come talk to me. It's not just a waste of time. It actually affects your dev cycles and productivity. You wait for something, you lose the context, you should work faster. So if this is a problem that you are suffering from, feel free to come and discuss with me. But this is not the topic of today's talk. We are going to talk about object-oriented programming, and the goals are to discuss the basics. And we would start with the basics because we are in the back to basics track, but it would be quite quick. Even though if there is any question, please just shout your question. And then we will discuss and understand alternatives and trade-offs, which is, I think, an important part of this talk. So let's start naturally with part one. Object-oriented programming. So the idea is quite simple. We want to put the data in the center. Usually, I teach, as I said, and when I give a big assignment in an object-oriented course, I ask my students, well, if you were in a procedural language, like in C, what was the first thing that you would think of when you get a big assignment? Well, the first thing is life sucks, but I mean the one after. So the one after is what would be our functions. And if you are in an object-oriented programming language, the first thing would be what are our classes. So the data is in the center, and then you later on think about operations. And the operations do have context, which is quite missing in a procedural language. So this is quite important, and there is a reason that object-oriented programming are out there anywhere. I mean, most probably, if you are programming today, you know what is object-oriented, and you are using object-oriented programming in a way, because it is helpful. Classes and objects. A class is the code that describes an entity. The object is the actual instance of the class. Like, for example, we have a class widget, and we have in our main a widget object. So W is an instance of a widget. This is how we do it in C++. Stick to what you do. This is the main idea of object-oriented programming. I mean, it is very misanthropic in a way. It doesn't mean that you have to do that. You can, keep your personality, but your code need to be like that. Your code need to take care of its own business. And once a class starts to take care of other business, something is broken, something is not encapsulated. So this is the first very basic idea. Single responsibility. A class should only have a single responsibility. This is true also for functions. I think you all know that. I'm just reminding you the basics. And now we would try to start with a crash syntax course. So it would be quick. Again, if there is any question, feel free to stop me. This is how a class looks like. We have a class point. We have two data members, X and Y. They are in the private section. We have here a constructor right after the public declaration. The constructor is using constructor initialization list. We would have a slide on that. We have a set function with a mutating function, which can change the object. Move also is a mutating function. Where is the implementation of move? Not here. Most probably it would come in the CPP file. And we have the print function, which is const. Quite simple. Don't forget the semicolon at the end. In the main, we would create points, like point P1, and we call functions on P1. If we create a const point, then we can call only the const functions. So far, very basic. The public can be accessed by anyone. We have also protected that can be accessed by the class itself and its derived classes. And we have the privates for the stuff that should be accessed only by the class itself. If we are using struct, the default privileges in a struct are public. In a class, it is private. By the way, there is also difference in the default inheritance mode between class and struct, but this is not so important for us right now. So this is the second bullet. Data members. The data members, each object has its own copy of the data members. This is the basic idea. Usually, I would say always should be private. I mean, you should have a good reason for having a non-private data member, and there isn't any good reason. And there is no default initialization for primitive types, if not initialized, which means they would be garbage. I think that I want to emphasize these two. Keep your data private. Remember that uninitialized members are uninitialized. Of course, if this is an object, then it would call its own constructor. Member functions. The operation that can be performed on an object, it might be public, even though we may want to have private member functions. In fact, yeah, helper functions, things that we do not want to expose, keep them private, even if they are methods. We need an object to call the method, and then the method can access the members of the class. And it is not part of the object size, of course. So if I want to emphasize, I would emphasize these things. Object size. Object size would include all its members, the members that come from its parent. It may include additional parts like pointer to a vtable. And it may include padding. So if you are relying on your own calculation of the size of the class, don't do that. Use sizeof. Padding is a real thing. The compiler may add some pads, some padding between data members in order to align them. So you should know of that. And then the size of the object, by the way, may differ between architectures and between compilers. The separation between header and CPP, we just mentioned that before. Like, for example, in this case, set was not implemented in the header file, and we implement it in the CPP with the scope resolution operator, which is the : right? And it is important to note that if we implement a function inside the header, inside the class, we just ask the compiler to make this function inline. So print here will request print to be inline. On the other hand, set is not. Even though the compiler can, in some cases, make things inline, even if you didn't ask for that. This pointer, this is the pointer to the calling object, to the object that got me into the function. In this very primitive, very naive example, we just want to print the address of the object, so we print this. By the way, the casting here to void star is not mandatory. You could just print this. It would work. I just wanted to emphasize that I just want to print it as an address. Okay. Constructors. If you do not have any constructor, then there is a default empty constructor that many people say does nothing. No. It calls the empty constructors of the members. It calls the constructor of the base class and the empty constructors, the default constructors of all the members, which is good. In many cases, this is what you want. If you do not have an empty constructor, I mean you implemented a constructor which mandates some arguments, then you must call it with arguments. You can overload constructors. In C+11, you can call a constructor from another one. We would see it on one of the next slides. You can use default arguments on constructor parameters, which means that you may have a default constructor even with a constructor that expects arguments because you have defaults for all of them. And we would see constructor init list. As seen in the first example, with the colon, we want to initialize the members. So let's take another look at that. We have here the constructor point that gets two integers and initializes x and y. For rectangle, we have down below another constructor which gets 2 points and sends them by the way, to a constructor that I cannot see on the slide, which means I didn't implement it and yet I have it. I'm initializing the internal points inside the rectangle, TL and BR, with small TL and BR, even though I don't see here which constructor am I calling there. Rectangle is initializing its own points with the copy constructor of point. And we didn't implement the copy constructor, but we have the default copy constructor, which is fine. Now, in this case, inside class rectangle, we had to use constructor initialization list. Because if we would try to initialize the internal points, TL, BR, inside the body of the constructor, not in the constructor initialization list, we would get compilation error because point doesn't have an empty constructor. Point must be initialized before it is being used, it is being called. So here, if we would not initialize points in the constructor initialization list of rectangle, we would get compilation error. And in fact, there are four cases where you must use constructor init list. Well, there are other reasons for using constructor initialization list, which is efficiency and correctness. Well, why efficiency? Because when something is being assigned inside the constructor body, it was born just before. And suppose that when it was born, when it was created with the default constructor, some initialization occurred. And then I just override that with another thing, then it is not so efficient. So I prefer to initialize my members in the constructor initialization list, and this way I know that they get the values that I want to send them, and they are not default initialized and then being override inside the constructor body with something else. So this is for efficiency. For correctness, I know that when I'm inside the body of the constructor, my members are initialized, which is a good thing. And in some cases, I must do that. And these are the four cases where I must do that. If I contain an object, like the point in the previous example, which do not have a default constructor and I don't provide any initialization on the declaration. What do I mean on initialization on the declaration? I could have, on the first line of class rectangle, initialize TL and BR there, which is C++11 syntax. I mean, you can send some initialization in the declaration of your members. So I could have done that, but I don't want to because I want to initialize that with arguments that I get from the user. In which case, the only possibility is to use the constructor initialization list. So this is the first case. The second and third case come together if you have a const or reference member. Const and reference members must be initialized when they are born, so they must be initialized in the constructor initialization list or on their declaration. But again, if you want to initialize them with user data, then in the constructor initialization list. And the last one, base class. If you have a base class which does not have default constructor, then you must call the constructor in the constructor initialization list of the derived class. In C++11, you can also do constructor delegation, so you can call another constructor, like in the second one, I'm calling the first one. So in the constructor initialization list, I'm calling the first constructor rectangle with, in this case, two temporary objects. Well, temporary object is not new. It's out there from C++98. I'm not showing in this deck of slides another thing that was added in C++11, which is constructor inheritance. But you can look it up. Constructor inheritance allows me to inherit a constructor from a base class. Anyhow, this was constructor delegation. Copy constructor. Copy constructor allows me to implement my own logic for how I want to copy something. This is a signature. It is used when creating a copy. It is also called automatically when passing objects by value. Not always. In some cases, the compiler just do some copy elision. Oh, I don't need to copy. I can just create it there. In some cases, it would call the move constructor, which is not part of our talk. There is another talk on move semantics as part of the back to basics. But when you should call the copy constructor, I mean, the compiler realizes that, oh, I need to create a copy, then the compiler might call your copy constructor automatically. If you don't want to implement your own, I mean, if you do not implement a copy constructor, then you get the default, and the default, in some cases, people say that the default does a shallow copy. That's not correct. Because the default calls the copy constructor of all the members, which is member-wise copy. And member-wise copy is not necessarily shallow copy. Suppose that one of my data members was a pointer, then the default copy constructor would copy the pointer, which we would call shallow copy. But suppose that my members are a vector and a string. Oh, so the default copy constructor would call the copy constructor of the string and the vector, which is not shallow copy. This is why I emphasize that this is member-wise copy, which is good. In some cases, you say, I don't want to implement the copy constructor because the default is fine. It calls the copy constructor of my members. What happens if I try to implement a copy constructor with this signature? Which means, oh, I have a copy constructor. It is allowing you to copy, but in order to get into the copy constructor, it has one small request. In order to come in, you must come with a copy, because it gets by value. So if it would compile, this would be an infinite recursion. But it doesn't compile. The compiler is smart enough to say, oh, this is not a valid signature for a copy constructor. You can try that. If it would have compiled, then it would have been infinite recursion, because it's something like, I don't know, a bureaucratic office saying, oh, come in, but first you have to go through the other office, and then you come to the other office. It's the same office. And you need to fill some form. But first you have to come to, okay, it's infinite loop. What about assignment operator? So this is the signature of assignment operator. It is used when you assign an object of the same type to myself. Don't confuse with copy constructor. They are not the same. They are quite similar, but they are not the same. If you don't implement your own, you get the default. And again, the default does member-wise assignment. Member-wise assignment. Oh, it says here members copy, and when I emphasize it, somehow members assignment. This is a copy-paste bug. I mean, I copied the slide from the other one, and I did it there, and I have to slide 29, I have to fix it. Anyhow, member-wise assignment, okay? Which is good in many cases, because if I have two members, a string and a vector, we just add them, right? And I'm not implementing my own assignment operator, then the default assignment operator would do just fine. It would call the assignment of my members. If you do have a pointer, then this is something else, and then we would call it shallow copying or shallow assignment, which might be not good. But in many cases, it's good. Can I implement assignment operator as a global function or a friend function, getting two arguments? First argument is who to assign to, and the second one, who is being assigned. I'm assigning A2 into A1. Can I do that? And the answer is, no, you cannot, because you have to override the default. And the default is considered as a member. So no, if you try to do that, you do not override the default, it would not work. Don't do that. Okay, another one. Can I implement assignment operator that gets by value? And the answer is, yes, you can. Syntactically, you can. Does it have any logic? Should you do that sometimes? And the answer is, well, there is some kind of idiom, copy and swap idiom, that relies on that. So you may see that in actual code. The idea is that when you come into the assignment operator, you already have a copy at end. So you just have to move from the copy. So this is a way to implement a single assignment that would actually handle both the move and the copy. The move assignment and the copy assignment. But this is not a move semantics talk, so I would not dive into that. And by the way, Howard Hinant, the man behind move semantics, would say, no, 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 don't do that. It would save you from some coding, but it would be a bit less efficient. Implement both, the copy assignment and the move assignment. Nevertheless, you may see people do that. Okay, this is valid. You can do that. Constructor can be used for casting. In this example, we have a constructor in class A, which gets an int. And then on the right side, you can see that when I call f, the almost last line, the line before the last, f with 1, even though there isn't any f that gets int, f expects a, it would compile. Because the compiler says, oh, I can create a from an int, but it works only for const reference or value, not for L value reference, which is not const. Okay. If you want to block that, you want to say, oh, I don't want this casting, this implicit casting, I want it to be explicit, then you add the explicit word on the constructor. And it is quite important. Jason Turner talked about that in his talk about improving your code. So I want to discuss an example. I have two classes in the standard library, one with explicit constructor, another one without, with a constructor which is not explicit, vector and string. String constructor is not explicit. You can create a string s equals hello, okay? You cannot create a vector v, like vector int v equals 10, with 10 being the size, which means that which one of them is explicit? The vector. The vector is explicit, it expects the size, but you should pass the size in brackets, right? On the other hand, string allows you just to send a char star, a const char star, or a char star, and a string would be created implicitly. What is the reason that string didn't put explicit on the constructor? String allows implicit conversion, while vector does not allow. What is the reason? When should we add explicit? There is a suggestion here that it is in order to maintain C compatibility. I'm not sure, because eventually this is a string. This is something new. So it relates to the state of the object. Now, if I have two strings being created from hello, I can tell you that they are the same, hello and hello. Like, for example, if I want to check if two strings are the same inside equality operator, I would just check whether their internal string is the same, right? So when I create a string from a char star, I actually provide the full state of the object. On the other end, when I provide 10 to a vector, is it the full state of the object or just, some attribute, some property of the object? Well, it's just some property, the size. It's not the full state of the object. I mean, if I want to check if two vectors are the same inside the equality operator, I would not just check the size, I would check the content. So I would tell you, if your constructor is getting the full state of the object, I'm okay if you do not put the explicit word. I mean, I got the full state, I can get it as a conversion, it's me. You just told me everything I have to know. On the other end, if your constructor is getting something which is not the full state of the object, usually I would tell you, put explicit on this constructor. How do you know if this is the full state? Would you use it as the only thing in your equality operator, or you have something else? So we talked about explicit a bit, mutable. You add mutable to the data members that might be changed even inside const functions. Can you tell me which members would you add mutable to? Something that might change even though this is the same object, which means that it is not part of the state of the object. It relates to the previous idea. I mean, if I have two vectors, both old, 1, 2, 3. The other one also old, 1, 2, 3. Oh, they're the same. No, but one, if I ask him what is the sum, would say 6. The other one would say, oh, I didn't calculate the sum yet. My sum is 0. Are you the same? Yes, we're the same. We're 1, 2, 3. The fact that one of them didn't calculate the sum yet is just, side information. It's state. Yeah, you can calculate the sum if you want. It would be 6. So caching. Caching can be mutable. Mutex, usually mutex is mutable. Why? Because when you lock the mutex, it's a non-const operation. And in some cases, you want to lock a mutex inside a const function. So you have to have it as a mutable data member. So mutable data members should be only on data that is not part of the state of the object. And in some cases, we have data inside the class, which is not part of the state, like caching, mutexes, and things like that. Well, we all know about the destructor. When an object dies, we would go through the destructor. We had a talk on RAII. I think it was in this room 2 days ago. Anyhow, you can watch it if you were not here. So destructor is being called when an object dies. When does object die? If it is a stack object at the end of the block, if it is heap on the heap when you delete it, global or static when the program ends, and the temporary object dies at the end of the statement. Like it has its own block, which is the statement. And then a destructor would be called. Rule of 0. It is the best if your class doesn't need any resource management, which means I don't have any destructor, copy constructor, assignment operator. How can I achieve that? Well, I'm using data which is managed. I'm using string, vector, shared PTR. I'm not using any pointers. I'm not using any resources that I have to manage. Oh, I do have to manage this one. Okay, so please, take it out to its own class, create your managed resource, and manage it there. And in your complicated class, keep the rule of 0. Don't mix managing resources with the logic of some complicated class. Like suppose that string would be implemented inside something else with its management of the resource. No, I want string to be isolated. Like, we started with single responsibility. So in some cases, you come to a class and you see that the class needs destructor, copy constructor, etc., but it manages too many things there. Oh, can you isolate the resource to its own class, and then you would get reusability. You can reuse it in many classes, and also manageability. You can manage the class quite easier. Okay, so rule of 0, go for that. But if you do need a destructor or a copy constructor or assignment, then you see that you need a destructor. Immediately block the copy and the assignment. Not tomorrow, not when I'm back from lunch. Immediately. Oh, you wrote a destructor, delete the copy and the assignment. Or if you want to implement them. But don't just add a to-do comment. To-do. Oh, I have to do something with constructor. Because then your class is broken. I mean, it has a destructor, but it might be that I'm pointing to the same resource from 2 objects twice, and then the destructor would delete the same object twice. No, block immediately. And then if you need that, the compiler would tell you, oh, you're trying to use a copy constructor which is deleted. And then you would decide whether you do not need to use, it was a bug, or, oh, I do need, I have to implement my copy constructor. But start with blocking that. This is Scott Meyer's efficient C++, very old advice. Back before C+11, it was put it in the private without implementation. But since C+11, just do the delete. The rule 5 says that you should also take care of your move operations, but I would not discuss move because this is not the talk of today, not my talk here. So move semantics is important, but there is another talk in the Back to Basics track. Let's talk a bit about inheritance. Why? Well, code reuse, we want something that we have already, but a bit differently, so we can reuse by inheritance and polymorphism. Polymorphism is very important. Polymorphism is the ability to treat different objects, different kind of objects, different classes, the same. I mean, person and student are quite the same if I, send them to a party. Maybe the student just, dance a bit odd, but he is a person at the end. So I want to treat them the same. Let's start with simple stuff, constructors. So I'm calling in this example the base constructor, okay? I must do that in this case because I don't have, in this example, an empty constructor in person. The destructor would be automatically be called. So when B dies at the end of the block, B would call the B destructor and then the A's destructor. And there is a comment here Because somebody can say, oh, but A's destructor should have been virtual. We would say something about virtual destructor, but I assume in this example that I'm not going to use A and B in a polymorphic manner, which means I would not allocate B and hold it with the A pointer. If you are going to do that, you need a virtual destructor. Because when you would delete, the compiler would not know which one is being deleted. You have to delay the decision to have the information at runtime. But this is not the case here because I'm just creating B on the stack. I know that this is B is being dead, B destructor, and then A is destructor. Polymorphism allows me to call a function on somebody. In this case, pet is a reference to a pet. Pet with a smaller p is a reference to a pet class with a capital P. And I call it function. And it might be that pet here is a dog, or maybe it's a cat. I don't care. Maybe the it function behaves differently. This is why it's a virtual function. And then I can send it any kind of food. Suppose that food is a base class. Well, I can send something that derives from food. The dispatching in C++ is only based on the calling object. I mean, if you have two functions, it that gets macaroni and it that gets generic food, and you said a food star that in runtime points to macaroni, you would not go to the macaroni function because the runtime dispatching is based on virtual functions, on the calling object, and not on arguments. So if your argument is a food star, or in this case, a food ref, you would go to the food ref function. Even if there is a better match at runtime, I mean, oh, it's a macaroni, and I have a function that expects a yeah, but the compiler saw food as a ref. You cannot dispatch based in runtime on an argument. There are methods how to do that. You can switch it back to be a calling object. There are ways to do that. But the thing that actually dispatches to a different function here is the calling object, which is pet. So we have virtual functions. We have make sound in this example for pet, dog, cat. And naturally, cat does meow. Dog, it depends on the culture, right? Ruff, ruff, or something else. And you should note that all of them must be const. Or if one of them is const and the other is not, since I'm using override, saying that, oh, I'm overriding the function from the base, I would get compilation error. So they are all const. Now, since I did the equals 0, it means that, oh, they are pure virtual, which means you must implement it otherwise in the derived, otherwise the derived would also be abstract. And an abstract class cannot be instantiated. So you cannot use pet just as a pet. I cannot create pet, which makes sense. What would you do with a pet? I mean, you should have an actual pet, not, can you walk a pet? I don't know. So don't create a pet. And the compiler would not let you do that. Usage example, command pattern. I want redo or undo stack. So I want any operation in my program to be, I want to be able to undo that. So I put inside a stack all the operations, and then when I call undo, the operation knows how to undo itself. But there are different operations, right? So I need different commands. So I have a command base class, and I can inherit from the command base class the different specific commands. Each one would implement its own undo function. Makes sense, right? This is an example of using inheritance and polymorphism. So let's summarize its intermediate summary. Object-oriented low-level design principles. A class should represent a single thing, break complicated entity into several smaller classes, use composition in inheritance properly, keep abstraction, implement your code for a generic interface, like, for example, for a command, and then you can use it with different implementations of command. Also, hide your privates. Keep clear and simple API, and try to keep your classes under the rule of 0. We are in part 2. Beyond the classic model. So C++ is not just an object-oriented language. It's beyond two steps saying that. It is more than that, which means, oh, in some cases, I would not go to the obvious object-oriented approach or the obvious object-oriented solution. So I want to discuss with you when and why not to use the classic encapsulation or delay inheritance or avoid inheritance at all. Let's start with array of struct versus structs of arrays. Usually, if we have persons, I want to create a class for a person, and if I have if I have a list of persons, I would create a list of persons, or a vector, or a container of persons. In some cases, I would prefer to have a container for all IDs, a different container for all names, and another one for all ages. I mean, I break the class into something that actually does not look as object-oriented. And the reason is efficiency, performance. Suppose that I want to run on all names to do something. Suppose that I want to run on all ages to do something. Memory locality. I have in memory the next data that I need, which is important. So in some cases, don't rush for that. Don't do it just like that because, oh, we heard that it is more efficient. No. But you could see that in some cases, especially when there is a big, a massive data flow, data analysis on a certain data point, on a certain member in the class, and after doing some performance analysis, we may realize that we do not want the encapsulation of a class, we want a struct of arrays and not array of structs. So you can find discussions on that, you can find talks about that. There are many, okay? And again, this is only if you see that you need that. Don't go for that just like that. Let's talk a bit about inheritance. Inheritance is overrated. And it is not me saying that. Sean Parent in 2013 had a talk, inheritance is the base class of evil. And inheritance in some cases is tricky. Let's take a look. Who should inherit from who? Which one should be the base class? Which one should? So do we have rectangle as a base class and square inherit from a rectangle or vice versa? Let's try to analyze that. Well, rectangle has a width and height, and square has only one. So it makes sense that maybe square would be the base. On the other hand, square is a rectangle, and rectangle is not a square, which is the more important part. The more important part is the Liskov substitution, which actually says that the derived class should be able to replace the base. So if I can do something with the base, the derived should be kind of the base. In which case, which should be the right one? Well, square is a kind of a rectangle, which doesn't, the properties doesn't fit so well. You can find blogs on that. Okay, you can see different approaches of how to achieve that, but it is tricky because in many cases we do the wrong one, and having rectangle inherit from square is a sin. I mean, you would pay for that in your code. You would have ifs, you would have type ID, you would have dynamic cast, you would have a mess. So you have to preserve the actual model of your data. B is kind of A, so the inheritance should be B derives from A. Let's talk about employee inheritance. I have an employee, which is a base class, but in my organization we have developers and QA engineers, and let's assume that they behave differently in some functions. Because if the only difference is your role, then I don't need a different class. But let's suppose that there is some kind of different behavior, some kind of different implementation for some of the functions. What do you say? Is it okay or is it wrong? Well, something bothers me here, and the thing that bothers me a bit is that in some cases a QA engineer at a certain point wants to become a developer. And we want to, it seems usually in some cases as kind of a progress. And we want to advance him to be a developer, okay? And then we tell him, but you have to know, we need to do something. We need to first kill you and then create a developer, and you would be a developer. Usually it's going to be fine. Why we have to kill you? Because we cannot, change the type of an object. You are a QA engineer. You are an object. So we have to kill you. And he says, and what about my name? Oh, we would copy your name to the other object. And what about the other stuff? We would copy everything. but we have to take care of that, which doesn't make any sense. Why shouldn't we just keep you alive as is and just change something, okay? Now, it comes even more complicated. Suppose that we also have internal employees and subcontractors. But also, the internal employees and contractors are QA and developers. And I would tell you that I see stuff like that in real code. Don't do that. But we tend to try to model the data that we think of directly into classes. No, don't do that. Because then you would come to that. Oh, since developer, I don't want to implement the logic of developer twice for the internal and subcontractor. So I raise it up, and then I would wind up with multiple inheritance of developer, which is subcontractor, and a developer, which is internal. And I see stuff like that occasionally. This is not a solution. Don't do that. We do that occasionally. So what is the solution? It is quite easy. You should have an employee. It's a very universal message. An employee is an employee, right? It's universal. It sounds good. And then you have employment type and a role. How do we call this pattern? This is a state pattern. State pattern says that you can model a state by inheritance. So we delay the inheritance to the property. It's not a type that is different. Oh, you're an employee. It is a very universal message. Go with that. Try to have it always. I would tell you that the state pattern, I found the state pattern to be the most important pattern of all. Whenever I use or I refactor something to state pattern, things start, like in a gravity to fall into the proper place, to become easier to maintain. So the state pattern says that encapsulate the different behavior in a state, in a property, and then you can have for the property the proper class. And you can see that the number of classes would be much lesser. I mean, if I have 4 attributes, and for each attribute I have 5 options, the number of classes that I should create in order to model all possibilities is 2 to the power 5, 5 to the power 2. I said, let's do it again. I have 4, let's say 4 properties. Each one has 5 options, right? So it is 5 to the power 4, okay? But if I go with the state pattern, I just have for each one of them its own hierarchy, and then I just pick from each hierarchy the state. Use that. It is the most important, this is what I say, the most important design pattern. Now, a state pattern is a brother, a sister, a sibling, strategy. It's almost the same, but usually strategy, we call strategy when the difference is only in behavior and not in state. I mean, I can behave like that, or I can behave like that, so I can, inject the policy or inject my algorithm for something. Now, if it does not change your actual state, then we call it a strategy. But you can see that the diagram is the same. I mean, in the Gang of 4, in the design patterns book, it has its own item. But eventually, you would implement it quite similarly. Pet inheritance. Should I have a pet, a dog, and a cat, or not? Now you can say that usually a dog does not become a cat, right? So, seems reasonable. Yeah, you're a dog. You would not become a cat. Not true. A dog can become a cat because we model the information. We do not model the actual cat. Suppose that we have, a vet shop. Okay, somebody comes and we type the information, and then you can come in. Oh, it's a dog. I just created it as a cat. Wait, I need to fill it again. What is the name? I just told you. You just have to change it from a dog to a cat. No, it's a whole different form. I have to refill it. Why? Because I have to kill the cat and create a dog. Now, if I would say, well, a pet is a pet, it is a pet type, So all the information that is in the pet is in the pet. The name, it doesn't really matter if it is a cat or a dog, etc. So I would tell you the state pattern in many cases rules, even if you think, no, I would just inherit the type. No, keep it as a single type, a very universal message, and go with the state pattern. You would thank me for that later. Issues with inheritance, changing type in runtime. You have to kill him in order to create the new one. I want to avoid that. Inflation in derived classes. Again, state pattern or strategy pattern solves that. If we force the user to be in the details of our internal design, I mean to know which type she needs to create, this is also in many cases an issue, and factory method or abstract factory can help there. I mean, I want you to tell me what you know, and I would decide which type to create. And you would just, get the generic type back. I don't want you to need to decide which type to create. And then I would go to a factory. Inheritance design principles. Scott Meyer says, make non-leaf classes abstract. Herb Sutter says, don't derive from concrete classes and make virtual functions private. And I say, users should work with a universal type. Same type represents all. Keep your inheritance for internal state or strategy. Try to do that. Prefer to have stateless abstract classes, pure interfaces. So the name is not in the base class. Why? Because if I change my role, I just want, all the generic stuff that I don't have to change to be preserved in the universal type that does not change. And if a base class does manage data, keep it very small and specific. Don't have a base class that manages many things. Oh, I want the generic stuff, the common stuff to be in the universal type that is not in the hierarchy, that just holds the hierarchy, that just manages the states. Polymorphism versus templates. I'm not sure that I would go into the code, but suppose that we want to implement a generic volume function for any prism. I want to calculate the volume of a prism, okay? It's a very simple equation. I can do that based on polymorphism and based on templates. Now, I would go in this case, in this scenario, with polymorphism. Why? Because there is a logic in having a hierarchy of prisms. But for some cases, there is no logic, there is no sense in having an hierarchy just in order to have functionality. Suppose that I want to sort something. Should I have a hierarchy of sortable? I mean, should I inherit from a sortable class in order to be sortable? Well, Java says, yeah. C++ says, no. You could use templates. I mean, you should just come with the less than operator and you're done. Duck typing. So I would go with duck typing and templates for any type that I need your functionality. Okay, just bring it. I would use it in a generic code. So I would give you another example. I would not go into this code, but the slides would be published. So you could go to the example and you can do the comparison between the two. Let's shortly have another idea, another example. TCP connection and UDP connection. I want to create code for TCP connection and UDP connection. I can use inheritance because some of the stuff is similar and some different. I prefer to go with templates. And the reason is performance. I don't want virtual functions for that. And usually I know at compile time that I'm going to open here a UDP connection or a TCP connection. So I know what I'm going to do. I don't need any virtual call. I just prefer to say with a tag that I'm using the specialization, the specialist version of TCP or the specialist version for UDP. So in many cases where we know what we're going to use and we do not need the runtime dispatching, we would go with templates. It is called, in some cases, static polymorphism. Static polymorphism. Oh, well, polymorphism is usually dynamic. No, when you see the term static polymorphism, it means, oh, can we do that with templates, which would mean that the compiler actually knows which flow we took, and then it's all statically linked, no dynamic calls, no virtual functions. Substitutes for inheritance, avoiding inheritance using templates or composition, like states. Well, the state itself may have inheritance. Lambdas, we didn't see lambdas, but in some cases, oh, I can provide you a lambda, and you would call it. Okay, that's fine. I don't need the entire, which serves like a state in a way. List iterator and vector iterator does not, I say necessarily, because the implementer can decide to have a base class. They do not have a base class. And I can have a code, I can in my code run on a vector iterator or on a list iterator with a generic code. Even though they do not share any base class. Don't go with inheritance if it is not needed. Inheritance of smaller things. Whoa, this is important. It actually reduces the complexity of your code. And hiding your inheritance inside this universal type, inside a proxy, inside a facade. So eventually, I'm using employee. To summarize, object-oriented programming is good. This is why it is so widely used. Use it. I'm not saying don't do inheritance, don't do encapsulation. Do that, but use it with care. Different problems may need different tools. Think of things that may change. Additional future classes and usages. I'm saying that because in some cases, we start with something small, which makes sense. But then it started with three derived classes. And the model that we took would grow to infinite number of derived classes, like the employee example, a QA engineer, a developer, a subcontractor. No, start with a state pattern. Now, when you start with a state pattern, usually you would have more classes than if you go with a direct model. Because initially, creating the state, creating the base class for each state, at the beginning, it seems like some additional burden, like a boilerplate, like something that is not needed. It is needed. You would see, otherwise you would have to refactor your code, okay? Think about the future classes and usages. Complex code. What makes code unnecessarily too complex? Classes that do more than one thing, methods that do more than one thing. Too much abstractions. You know that in computer science, every problem can be solved by adding another layer of abstraction, except for too many layers of abstractions. So when you come to too many layers of abstractions, okay, the code is too complex. And exposing your internal design, which includes your hierarchy. If the user doesn't have to know about your hierarchy, your different strategies, it is internal. Use the factory. I will decide which strategy to use. In some cases, you want the strategy to be injected. Okay, no problem. I would inject the strategy, but it doesn't mean that the user needs to do that. It might be there is another layer that decides which strategy do we need. Now, I'm talking about injection, because if we inject the strategy, we give the strategy to the class, then it is much easier to test. And in general, bad design makes things more complex. So let's recall. Object-oriented low-level design principles. A class shall represent a single thing, break complicated entity into several smaller classes, use composition and inheritance properly, keep abstraction. I mean, write your code to generic types. But also, hide your privates, which includes design decisions. The user doesn't have to be exposed to your design decisions because design decisions change. And you want to keep the liberty to change your design decisions without affecting the user. Keep clear and simple API, and try to keep your classes under the rule of 0. Any questions?
So you recommend state patterns to help. But one thing, if we're implementing a library, is making it hard to use incorrectly. So let's say that you were implementing a pet library. How would you make it clear that you're supposed to implement a pet with pet type dog instead of using just the dog class?
Right. So the question is, if we are implementing a library or an infrastructure, and the user would eventually need to know which type he should derive, which type he should create and derive from a base class, then yeah, it's part of the game. I mean, the user, if I go back to the proper slide, I may want the user to implement the pet type and not the pet. So it might be that when pet is born, one of the arguments that should be provided in the constructor is the pet's type. And then the user sees that a pet has to get a pet type. And now he says, oh, I have a dinosaur. I want to, small one. I want to use your vet shop for a dinosaur. Yeah, you can inherit dinosaur as a pet type. And this way I separate between the common stuff, which is in pet, and I don't want you to touch. I want to manage it in one place, and I don't want to replace it when, for example, oh, it was not a cat, sorry, I have to refill the form. And I think the user may be able to derive from pet type. I would give you another example for the same idea. Let's suppose that we are going to implement Excel, like a spreadsheet, okay? In a spreadsheet, we have cells. A cell can contain a formula, a string, a number. It can be empty. So I am proposing something. Let me know what you think. Let's have a cell as a base class. And from cell, let's inherit formula cell, string cell, number cell. And then when we do something with cells, we would just go to the cell and we would have virtual functions, like, for example, sorting or summing. And it would know how to do things with a different kind of cells. What do you say about that? And of course, the spreadsheet would hold a container, like a sparse matrix of cell pointers or unique pointers to cell. What do you say about that? You were here, you should say, no, because the universal message, a cell is a cell. And then cell wants to hold something, which would be, let's call it cell data, cell content, whatever, okay? And cell data would be the hierarchy. And I would tell you why. Because cell has other things, other than just the content. Can you tell me something which is not part of the content? My formatting, my style. Bold, italic, font size, color. Oh, it's not a string, it's a number. Ooh, I lost my formatting. Or I have to copy the formatting. No, the formatting is held by the cell itself. Now, when we begin, we know, in some cases, we do not see that. Assume that some data would come in. Assume that, the common stuff would be in the universal type. Have a cell. And then the spreadsheet is also more, less complicated, more easily maintained, because it only holds cells. By the way, it goes perfectly with value semantics. It goes very well with value semantics. And value semantics is being talked a lot these days because it helps us with correctness and efficiency and performance. Why? Because in multi-threaded environments, instead of sharing, each one has its own copy. We are able to have code which has less locking, okay, which can run in parallel. So it goes quite well with value semantics. Any other questions? Sorry for the long answer for this question. We have time for, I think, 1 or 2 more questions. Online question, maybe? Yeah, please go to the mic.
Do you have a recommendation on for creating objects on the stack versus creating on the heap?
So the question is creating objects on the heap or on the stack. I would start with the obvious. If I need an object for the current block, for the current function, I would always create it on the stack. If I want to send it back, in some cases I would create it on the stack and just, rely on moving it out. It would move out in C+11 and after. So since C+11, in many cases, where before we would go with either an output parameter that you send me and I fill, or allocating and returning allocation, we just go with, okay, you create a value, you create an object, and you just return it, relying on move semantics. So when should we have allocations? For anything that is, outliving many functions and it has to be handled in a certain, and even then maybe it can be on the stack. So I would try to have things on the stack unless there is a reason to have them on the heap. And in most cases, the reason is that the place where it is being created is not associated with where it should die. So, where should it die? I don't know, somewhere. Okay, so I have to, in a way, decouple the creation from the destruction, which is not the case on stack allocation. Any other question? So I would tell you thank you for being here.